Okay, now this one is kind of a weird one. Now, parts per million, where this is applicable is mostly kind of in environmental studies, and where they're trying to find out like toxin levels of different things, say in a pond, because really, say if we think about mercury, even though if there's mercury in, say, a pond, even though it could be a really, really, really small amount of mercury, the amount of damage or impact that it has on that environment is like huge, right? So it's like if you had just a little bit, just a tiny bit of carbon monoxide, well, even though it's just a tiny bit, it's a big deal, right? So we measure these kinds of, generally it's toxins that we measure parts per million in because they're the most applicable. We need to know if there's even a little tiny bit, right? So it's like 1 part per a million. Well, it still can have an effect. So in studies of solutions in the environment, we often encounter very low concentrations of like toxins. For very dilute solutions, we choose a concentration unit to give a reasonable number for very small quantities. So this is our parts per million. So the definition of part per million is the mass of solute, and generally we use grams, okay, divided by mass of solvent, again in grams. Then you times by 10 to the power of 6, and that will give you, like, it's a unit in parts per million. However, this calculation, if you want to do it a different way, it can be simplified by altering the units to incorporate the factor of 10 to the power of 6. Therefore, concentration in parts per million can also be like this. C is equal to mass of solute in milligrams, okay, because it's like such a small amount, divided by mass of solvent in kilograms. Okay? So the units, if you don't write part per million, the units for this is milligrams per kilogram. Okay? So 1 part per million is equal to 1 milligram per kilogram for units. So yeah. So let's see here. So because very dilute aqueous solutions are similar to pure water, their densities are considered to be the same. So like 1 gram per milliliter. So for example, in a chlorinated swimming pool, 1 part per million of chlorine is like 1 gram in 10 to the power of 6 grams of water, which is equivalent to 1 milligram of chlorine per liter of water. So the main thing, 1 part per million can equal, we can say it's like 1 milligram per liter. That's the same as 1 milligram per kilogram. It's just the way we measure water, you can say a kilogram of water is like a liter of water. Okay? So small concentrations such as part per million or part per billion or part per trillion are difficult to imagine, but are very important in environmental studies in reporting of toxic effects. So, for example, dissolved oxygen in natural waters is an important measure of health of an ecosystem. In a chemical analysis of 250 milliliters of water at SATP, 2.2 milligrams of oxygen was measured. What is the concentration of oxygen in parts per million? So here it seems like our best unit to use will be milligrams per liter, okay? That's our measurement of parts per million that would be the most applicable here. So now our concentration then is 2.2 milligrams of our oxygen, which is like our solute, divided by 0.250 liters of water. So this gives us 8.8 milligrams per liter, which then you could say is 8.8 parts per million. Right? If we put it into the parts per million kind of unit.